In this video, I'm going to do one question that is from the chapter Light based on mirror formula. So the question says that an object of height 8 mm is placed at a distance of 30 centimeter in front of a convex mirror and whose radius of curvature is given as 60 centimeter. We need to find the position of the image, that is V, size of the image, that is H, magnification M, and the nature of the image. Now, we also need to draw the ray diagram. So first of all, it's a convex mirror. So let's say if I make one convex mirror, and we know that in a convex mirror, the reflecting surface is curved outward. So can you erase a part of it? The reflecting surface is curved outward. That means this portion is painted. Now, if I make its principal axis, as you know, principal axis passes through the pole of the mirror. So this is what the pole of the mirror. Let's say this be the principal focus and this be the center of curvature. Now, by looking into the question, we realize that we have information that is the height of the object, that is H, which is equal to 8 millimeter. And the distance of the object is also given. Now, the distance of the object is indicated by U. As you know, object is always kept on the left-hand side of the mirror, irrespective of the type of the mirror. So since the object is kept on the left-hand side of the mirror, we'll be taking object distance as negative. By convention, it should be minus 30 centimeter. Moreover, it is important to remember that we do not need to convert them into same unit, as you should know that U, V, and F must be in the same unit, and H and H dash must be in the same unit. The interconversion is not needed. Now, further, when we read the question, it says that it's a radius of curvature, right? We know the radius of curvature as 60. So what you can see that the radius of curvature, as in case of this, the radius of curvature is on the right-hand side, and therefore, this is the radius of curvature, that is the distance from the pole to the center of curvature is called the radius of curvature, denoted by capital R. And this radius of curvature is on the right-hand side of the mirror, so we'll take this as positive. That is capital R here is the radius of curvature, and that is positive 60 centimeter. So therefore, the focal length will be half of radius of curvature, that is 30 centimeter. So you should know that the focal length, which is half of the radius of curvature, that is this distance. So this is 60 given here. So we may write over here as 30. So this is 30 centimeter and radius is 60 centimeter. We need to find the position of the image in this case, that is V here. So we need to find out V here. Clearly, we see that we can apply this mirror formula as we know the object distance and the focal length. So using this formula, we can find the So we have this F, we have U, we can find V. So if I apply this formula, the formula will be applicable here. That is 1 over F is equal to 1 over V plus 1 over U. Now, replacing the value of F here, the F can be replaced with 30 is equal to 1 over U. As you can see, object distance is minus 30. So write minus here and say 30 over here plus 1 over V. Now, if I transpose, this is 1 over 30 plus 1 over 30 is equal to 1 over V. So this is 2 over 30 is equal to 1 over V. And there it implies that this is divisible by 2. So V is equal to positive 15 centimeter. So we'll say that image is formed at a distance of 15 centimeter in behind the mirror, right? It has to be, because we are getting positive, so it has to be on the right-hand side. So image will be somewhere here. Image will be formed here, right? Now, what else we have to do is we also have to get the size of the image. For that, we will be applying this relation to get the size of the image. Now, what we have, the size of the object. So we are going to use this part of this relation, that is linear magnification, ratio of the size of the image to the size of the object is same as the distance of the image to the distance of the object. Now we have to get h dash. So I can say that h dash is what we have to find out. H, which is this height of the object, mentioned as 80 mm, and minus v, image distance is 15. So it's minus of 15, that divided by object distance, which is minus 30. So this gets reduced here, 15 one times, 15 two times. So by cross multiplication, we get 2 times h dash is equal to 8. That means size of the image h dash is 4 centimeter. So we also got the height of the image or the size of the image. Now we have to find magnification. Magnification, therefore, we are going to use this relation. That is m is equal to my h dash over h, and h dash is 4 and h is 8. So this is 1 over 2. So we can say that the magnification is 0.5. And you should be careful that you do not use unit like mm or centimeter, as it is a ratio of similar quantities, and therefore it has no unit. Now, once we have calculated this, we have to find out the nature of the image. Needless to say that image which is formed behind the mirror has to be virtual and erect. Now, regarding the diagram, ray diagram, what we are going to do first, since we are placing the object in front of the mirror, you are going to draw a ray here, incident ray. Let's say if I draw roughly a ray drawn parallel to principal axis appears to pass from the focus, right? Let me reconstruct it. Let's say I place an object. Say this with the object placed here. And you'll draw a line parallel, a ray parallel to principal axis, and therefore it should appears to pass through the focus. So it should be a broken line, and it will diverge in this direction. And the second ray, which is directed towards the center of curvature, let's say this be the center of curvature, shifting a bit. Then if the ray rebound back on the same path, and when these rays are produced backward, we are getting the image here. So this is how you will draw, but you have to use a scale for drawing this, not a rough sketch. So we have drawn the ray diagram as well, and we have calculated the image distance, the magnification, and the size of the mirror. Size of the image, including the nature, and the nature, as I said, that the image is formed behind the mirror, so it will be virtual and erect.